Welcome to HelpYourMath.com. In today's video we're going to be covering the greatest common factor, also known as the GCF. Now when you're doing factoring, this is usually the first step you're taking to your factoring methods, whether you're doing trinomials, binomials, or just multiple terms that are in a string of sums and additions and you want to factor by doing a greatest common factor. Now usually to do the greatest common factor, what we look for is what we call the LCM, which is the least common multiple between all terms. And our terms are usually separated by additions and subtractions only, because multiplication and division unite terms. So we're looking across additions and subtractions only to do greatest common factor. Now in most cases when we're doing the greatest common factor, we're looking for what they have in common. We're looking to extract it and use what we extract to divide each term. Because if we multiply, if we're looking at two things that have something in common and we factor one of them out, we want to set up a basis for multiplication so that when we distribute back what we had, we get the same thing. So this is multiplication, so when we're factoring it out, we want to divide each term by that term we take out, so that when we divide and multiply by it, we get back the original term itself without changing the problem. And now to do that, what we're going to do is run a series of tests here. So let's take a look at what we have here for the factoring. And our first problem here is 3x's plus 3. Now to do this, what we usually do is we identify the numbers in each term and the variables. And the first thing we notice is that there's only a variable in the first term. So we already know that the greatest common factor doesn't concern the variables. However, it does concern the numbers. And here we have numbers that are identical. And so what we know is that each term is divisible by 3, and since they're each divisible by 3, to create this, what we're going to do is factor out that 3 that can divide each term. When we factor it out, to get the solid term that you get after you do the greatest common factor, we're going to take what we factored out and divide each term by it. Now technically you won't have to do this every time you're doing it. I'm just doing it for this first one so you understand the principle of what the greatest common factor does. And here this 3 is outside and we're multiplying that. 3x divided by 3 gives us just x, and 3 divided by 3 is just 1. We keep the symbol between them the same. And so when we factor out the greatest common factor out of 3x plus 3, we see the greatest common factor is just a 3. But the whole factor term is 3 times parentheses x plus 1, close parentheses. So let's move on now and find some greatest common factors with the rest of these other 7 problems. All right? So here we have number 2. In number 2 we have 4x squared plus 2x's. Now remember, the greatest common factor won't always be a number that can divide both terms perfectly. Sometimes you don't get all the value of each term out, but what you do get is the factors of it out. So this time, instead of setting it up with a division, I'm going to set it up with a case of multiplication so you can visualize how this works a little better. And here if I break down 4x squared, I know I'm going to have 2x's times 2x's. And I also have a 2x over here. And if I set up 2x times 1, I can see the factor pairs already. I see my greatest common factor is the leading term here. And I want to extract this. And I want to leave in the parentheses set everything else. So here I have 2x's. And in the parentheses I have 2x's plus 1. And there I just factored out the greatest common factor of 2x's. While inside the parentheses what remains is 2x plus 1. And that's factored completely. Let's move on to number 3. And so sometimes what's best to do is to find a term that can create both terms with multiplication, or just finding what term divides both of them perfectly and extracting it through division. But I leave that up to you, whichever way you feel most comfortable. I would suggest that you practice with it a little bit, get your hands wet with it, and try to break things down as much as you can, because breaking them down makes things a little more evident to see. And here we have now 8x cubes plus 12x's. Now, when we're looking at the numbers, another technique we can use is looking for a number that makes both of the numbers that we see. And if we're looking at 8 and we're looking at 12, we know that 8 and 12 are both multiples of 4. So we know that the first thing we have to do here is factor out the number 4. Also, we look at the x variables. And here we have x to the third power, while here we have x to the first power. Another good technique is to take the smaller of the two powers and factor it out if they all have those variables. And so we're going to take out the x to the first power. Now what's left over is whatever is necessary to create the 8x cubed. We're multiplying with 4 x's. And we see here, if we take 8 and divide it by 4, we get a 2. And if we take x cubed and divide it by x, we get x squared. Now let's take a look at how we make this 12x's. So here we have a 4x. So here we have the 12x, and 12 divided by 4 is just 3. So here we're going to have the positive symbol comes over. 4 goes into 12 3 times. And x divides x perfectly, so it just goes away. If you need a little bit more help on understanding how to divide these exponents, you can refer to our exponent videos, right, where we cover everything dealing with exponents and how to do the reductions of powers when dividing or multiplying and when you're adding them. All right? And so, let's move on to number 4 here. Now we have a squared b cubed minus ab. What we want to do is factor out the greatest common factor again. Now here we're going to take a look at the exponents here, and remember, just like we did in the last one, when we're looking for what they have in common, we look at the numbers. There are no numbers. We look at the variables. Each of them have an a and a b, and the least power of these a's and b's in both sets are 1 and 1. So we just need to factor out ab, and what's left over? A squared divided by a is just a. B cubed divided by b is b squared. There's a subtraction symbol. And AB divided by AB is just 1. It's a perfect division. Moving on to number 5 here. 14x's squared, take away 7x's. Now in this case, we're looking to see if there's a number that makes both 14 and 7, and we know that number to be 7 itself, right? Because 7 times 2 is 14. So we have the 7 is the greatest common factor for the numbers. As far as the variables goes, they both have x's, and we want to extract the smallest power out of these two, which is x to the first. So we're just taking that x out. We're using the 7x to divide each term now. So 14x's squared divided by 7x's, that's going to leave us with just 2x's. While we have a negative symbol here, and then we're doing 7x's divided by 7x's, that will just give us 1. Moving on to number 6 now. Now these binomials have run its course. Pretty much they all work the same way when you're dealing with 2. It's a little bit easier when you just have 2 terms because you just see those 2 and it's easy to think about what they all have in common. When you move on to 3, it takes a little more examination, so be careful when you're running your routine on this one, all right? Because you're going to have to first start by looking at all the coefficients, all the signs of the coefficients, and then looking at each individual variable if they all share that individual variable. Whenever we're doing the greatest common factor, we're extracting what they all have in common. Not just what 2 of them have in common, but what they all have in common. All right? So make sure you're going through this carefully when you're doing it. Don't rush yourself. This is not a race. This is mathematics, and intelligence doesn't win by just being the fastest person. All right? So here we have 5x's cubed with y. Take away 15x squareds, y squareds. Take away 10xy's. So the first thing we want to do is analyze the coefficients. First off, we have a positive, negative, negative. So because the leading coefficient is positive, we're not extracting the negative that seems to be the majority here. We only extract it if it's the leading term's sign. As far as the numbers go, they're all multiples of 5, right? Because 5 is 5 times 1, 15 is 5 times 3, and 10 is 5 times 2. So we know the greatest common factor for the numbers are just 5. We can also examine the variables. Here we have an x, here we have an x, and here we have an x. And the rule is we want the least power of all of them, right? So the smallest power that they all share is x to the power 1. So we're going to factor out just an x out here. Then we look at the y values, and here we have a y to the first, a y to the second, and a y to the first. So we know what they have in common is the y to the first power. And again, we're going to extract this from each term. Now again, 5 times 1 makes 5. So we know the number that corresponds to this is a 1. We don't need to place a 1 inside. However, the x's, to make x cubed with x, you have to multiply this by x squared to get x cubed. So we'll put the x squared here. And to get the y, we already have the y here. We don't need to add it inside because it's already there. So when we multiply x squared by 5xy's, we get 5x cubed y. So now to make negative 15 with 5, we have to multiply by negative 3. To make x squared with 5xy, we have to multiply by x. And to make y squared, we also have to multiply by y. Moving on to the negative 10xy. To take 5xy and make negative 10xy, we know to make a negative number, it's a positive times a negative. And to make 10 with 5, you need 2. And finally, the xy just comes along from the 5xy. This times this will give us this. So we're done with the greatest common factor. And if we look close, they have nothing else in common, which is something we can go back and look through all of them and say they have nothing in common anymore. And that's how you know you're doing the right job. But make sure that when you multiply it back, if you're doing your check method, you get exactly what you started with, all right? So let's move on to number 7 now. And remember, if you don't know the multiplication of certain numbers, what you can do is take a base number and add it to itself and see what it becomes, right? Like for instance, 4 plus 4 is 8, 8 plus 8, 8 plus 4 is 12, 12 plus 4 is 16, 16 plus 4 is 20. These are all multiples of 4. Up here we had a problem with 4s, right? So here we see the 8, here we see the 12, and here we see the 4. This is times 1, this is times 2, this is times 3, right? Oh, well, we didn't have the 4 actually in this one. It was just the 8 and the 12 that were multiples of the 4. So here we see the 2 and the 3 correspond to the 8 and the 12 perfectly. And that's the way we want to work this out. And I'm only mentioning this now because here we have multiples of 13, even though we may not or know it or not. 26a cubes b plus 13a squared b cubes minus 39ab's, right? So we have 26a cubed b's plus 13a squared b cubes. Take away 39ab's. Now the numbers, the leading terms here, are all multiples of 13. 13 times 1 is 13. 13 times 2, 26. 13 times 3 is 39. So this is 1, 2, and 3. So each one of these are going to become one of these. So we know the greatest common factor between the three of them, for the numbers at least, is 13. And for the variables, we're looking for the least exponent of the variables they all share. And all of them have an a and a b. And the smallest powers of these a and b's are right here, the 1 and 1. So we're just going to place a single a and a b there with no exponents, because the exponent is 1. So now, how do we make 26a cubed b out of 13ab? Well, the only difference is this has to be multiplied by 2. We see the 26 is 2 times 13. And to make the a exponent come to 3, we need an a squared in here. For the next one, we put the plus symbol, and we have 13a squared b cubed, which we already have the 13ab. What we need is the a and the b squared. Because the powers, when we add, the 1 plus the 2 makes the b to the third. The 1 plus the 1 makes the a to the second. And finally, we have a negative 39ab. So our 39, which was negative, is going to be negative 3. And here we have a negative 3. And our AB already comes along for the trip from the 13 here. So we don't need anything else. And if we look closely, the three of them have nothing else in common. So we've successfully factored out the greatest common factor. Now let's move on to the last one, which is our special one, because it has a leading term that's negative. And usually what we want is to start our trinomials inside these parentheses without a negative term. Because all it means is that we're going to have to distribute something that's going to become negative after the distribution. It's better to factor out your leading term's negative symbol, because then everything within the parenthesis set is going to have a leading term that's positive. And if you factor in with greatest common factors, it's usually good to have a leading term that's positive. So let's take a look at the work of this one. We have negative 3x squared, take away 15x's, plus 6. And now we're looking at the numbers. And the number they all have in common is not only going to be a 3, it's going to be a negative 3. Because the leading term's negative symbol needs to come out with the number. And so this way we'll get positive numbers within the parenthesis set. And so negative 3 makes each of these numbers. And since we're factoring out a negative number, each term is going to change in symbol. This will become positive, this will become positive, and this will become negative. The only thing we have to worry about is what it's multiplying to make the term. So negative 3 times x squared gives us the first factor set. right? This produces negative 3x squared. A positive, since the negative 15 is going to become positive after we factor out the negative 3, to make 15 with 3, we need a 5. And along for the trip is the x coming. And finally, we have the 6. And to make a negative 3 become a positive 6, we have to multiply by a negative term. So here we're going to have a negative 2, because 2 times 3 makes positive 6. All right? Thank you.